So here we need to verify the following. We'll start a problem from the left hand side. So here on the left hand side, let's look at the numerator part. So the first term is cosine of 2a times cosine of 3a. So we have here is the product of two cosine function. Then we have the second term, so that's also a cosine of the product of two cosine function, cosine of 2a times cosine of angle 7a. The third term is also the same, cosine of a multiplied to cosine of angle 10a. Fine. This is divided by the denominator where we have three terms, and each of the three terms are product of two sine function. The first term being sine of angle 4a times sine of angle 3a minus sine of angle 2a times sine of angle 5a plus sine of angle 4a multiplied to sine of angle 7a. So how shall we proceed? Our goal will be to first convert the product to the sum or difference, meaning we'll have to use the transformation formula. That means if we have the product of sine A and cosine B, so that transforms as a sum of two sine function. If we have the product cosine A sine B, that transforms as a difference of sine function. Similarly, we have the product cosine A cosine B, sine A sine B, so they transform as a sum and difference of two cosine functions. So we're going to apply the transformation formula. However, we observe here that in each of the terms, the factor 2 is missing. So that's not a big problem. All we have to do is multiply both the numerator and the denominator with 2. So that means each term will get multiplied by 2, and also each term in the denominator will also get multiplied with 2. Now we are ready to apply the transformation formula. So let us begin. So we have here the first term is 2 times cosine of 2a times cosine of 3a. What we have is the product of two cosine functions. So we are going to use this transformation formula. So we will get cosine of angle. So let's take the magnitude of angle A is greater than B, meaning we will consider 3a to be greater than 2a. So we will have here cosine of angle 3a plus 2a plus cosine of angle 3a minus 2a. Moving on to the second term where we have 2 times cosine of 2a 7a. So we'll come back to the sign in a moment. We have cosine of 7a plus 2a. We have plus cosine of 7a minus 2a. But what we'll do, we will multiply each term with negative because we have a negative sign here. And then finally, we have cosine of 2 times cosine of a times cosine of 10a. So that's going to be cosine of 10a plus a added to cosine of 10a minus a. Okay, let's come back to the denominator. Now in the denominator, we have the product of sine and two sine functions. So that means we'll have to use this particular formula. So we have cosine of angle 4a minus 3a minus cosine of angle 4a plus 3a. Then we have minus of 2 sine 2a sine 5a. So we'll have negative cosine of angle 5a minus 2a plus cosine of angle 5a plus 2a. Be very careful with the signs. Then we have finally cosine of angle 7a minus 4a minus cosine of angle 7a plus 4a. So let's further simplify. Now we will be getting cosine of angle 3a plus 2a, so that's 5a. So cosine of 5a plus cosine of angle 3a minus 2a is a minus cosine of angle 7a plus 2a, so that's 9a minus cosine of angle 7a plus cosine of angle 11a plus cosine of angle 9a whole divided by, we have cosine of angle a minus cosine of angle 7a minus cosine of angle 3a plus cosine of angle 7a plus cosine of angle 3a minus cosine of angle 11a. Fine. You will see that a couple of terms will get cancelled out. So we have here cosine of negative 9a and positive cosine of 9a cancelling out. Then coming to the denominator, we have negative cosine 3a and positive cosine 3a cancelling out. We can also cancel out cosine 7a and negative cosine 7a. So here I have made a mistake. This is cosine of 7a minus 2a. So that will give us cosine of 5a, not 7a. Which means that cosine of 5a and negative cosine of 5a also gets cancelled out. Now we are left with cosine of a plus cosine of 11a in the numerator. And in the denominator, we have cosine of a minus cosine of 11a. So we are left with the sum of two cosine functions in the numerator and the difference of two cosine functions in the denominator. So we'll use the other transformation formula, which transforms the sum or difference of trig functions to their respective products. So let's state those transformation formula. So as you can see here, we have the sum and difference of two sine function and the sum and difference of two cosine functions. So they are transforming into the corresponding products. So for this particular problem, we'll only need the sum of two cosine and the difference of two cosine function. So we have 2 times cosine of angle. So we'll treat alpha to be a and beta to be 11a. So we get a plus 11a divided by 2 multiplied to cosine of angle a minus 11a divided by 2 whole divided by the denominator, which is the difference of two cosine functions. So we get negative 2 times sine of angle a plus 11a over 2 multiplied to sine of angle a minus 11a over 2. So this is going to give us 2 times cosine of angle. So a plus 11a, so that's 12a. 12a over 2 is going to be 6a. Multiplied to cosine of angle, so we have a minus 11a, so that's negative 10a. The negative 10a divided by 2 is negative 5a. Whole divided by negative 2 times sine of angle, we have 6a multiplied to sine of angle negative 5a. Now we know that cosine is an even function. So even function would mean that cosine of negative 5a is going to be equals to positive cosine of 5a. Right? And sine is an odd function. That means sine of negative 5a will be equals to negative sine 5a, which will make the new expression 2 times cosine of angle 6a. So we'll have positive cosine of angle 5a whole divided by, so we have a negative 2 times sine of angle 6a. Now sine of negative 5a becomes negative sine 5a. So since we already have a negative number here, so we'll make it positive to get positive sine of angle 5a. Now 2 and 2 gets factored out. So we are now left with the ratio cosine 6a over sine 6a, which is nothing but the cotangent function. So we get cotangent of 6a multiplied to the ratio cosine 5a over sine 5a. So that's also the cotangent function, but the angle will be 5a. And this is the expression on the right hand side. Hence, we have successfully showed that the left hand side is equals to the right hand side. Hence, proof.